And welcome back to Slug Glove's Insect and Bug tier list. First of all, I'm going to start with the ladybird. This one, a little bit controversial. I'm going to put it in S tier. Secondly, we're going to use the ants. I'm going to put them in A tier for ants, but I'm going to move them into S tier, for they are just so lovely. And the final insect of all, this Devlog, and that's going in D tier. And welcome back to Devlog. In the last part I worked on 2D mobility and movement, and in this part I am working on the turning around function, which you would think is not a complicated function, but it kind of is. So, how do you turn in a 2D game? An excellent question. You press left, you turn left. You press right, you turn right. But it's not that simple when you incorporate things like loop-de-loops or running up walls or running on ceilings into the equation. For example, if I was to run on a loop-de-loop, this is a circular loop, the player could be holding right to run right, then they go up the loop, they continue to hold right, they go into the roof of the loop, they continue to hold right because the player is still moving right relative to their facing direction, they move down the loop, they continue to hold right, and they are back on the ground, you continue to hold right, and you move the entire time because you're just holding right, and you don't have to adjust to the loop's direction. However, some players won't navigate the level like this. For example, some players when going on a loop will hold upwards to go upwards when they are running up the loop, they will hold left to run left when they're on the left part of the loop, and down to run down when they're on the down part of the loop. So I have to recognize what inputs the player is making, and if they are actually trying to turn based on these inputs. This sounds pretty complicated, but it's actually pretty simple. All I do is I keep a track of what the player's last movement input was, the previous frame. Next, I will check what the player's current input direction is. If the player's current input direction is nothing, they're not even pressing an input direction. So we can turn normally the next time they press an input direction if we need to, because the player has let the control stick hit a neutral position. This means they're not holding their control stick to run in a specific direction or trying to move in an alternate direction. They've just stopped moving altogether, and the next input, if needing to turn, can turn the player as it organically would. The next thing we check for is if the player is holding the controller in a vastly different direction. So if the player was holding left and then they immediately press right, this will have 180 degrees of change. So this will detect that the player is making a vastly different input direction and are probably trying to turn their character. The actual limit for this is around 36 degrees. I just felt like this was the reasonable amount that the player would naturally turn their axis in a single frame in order to try and turn, but it's just an arbitrary number that I figured out through testing. Once we have this detection of if the player is trying to turn or if the player has made no axis and is then making a new axis, we will then find the direction the player is making. For example, if the player is facing right and their input is left and they're on stable ground, the player will just move towards left, and they will be triggered into turning. However, if the player is on a roof, for example, and the player is moving in the right direction relative to the player, so this is in the game space, they are running towards the left, and they make a vastly different input direction, and the direction is towards the left, we can relatively say that the player is still trying to run in the left direction because they are on a roof and they are pressing their left input to move left, so we won't actually change our player's rotational direction when they're on a roof because they have made a very vastly different inputs. To summarize this long-winded section, we check if the player is making an input that is different than their current input or their previous frame's input by a reasonable margin. We check if this input matches the current facing direction of any player. And then if all this works out, we actually turn the player. But how doth one actually turn? Well, that's an interesting question. I have different turn functional mechanics based on your current speed. On the ground we have 3 different turn mechanics, this being a very quick turn, which is, I believe, 3 frames. So it's very fast, it's very quick, it's very snappy, and this is if you're not moving very quickly. If we are moving reasonably quickly, you have a medium turn. This has a little bit of skid and a little bit of momentum based on when you're actually turning, based on your actual speed of when you are turning. Then we had the final turn mechanic. This is a really big skid. This is if you're running very quickly and then you turn, so this is carrying forward our momentum. These are all the same substate because they're the exact same function, but they have different information classes that are being actively read from depending on which of these was used. If you don't know what that means, I have different class information files for each of these dash mechanics, and then depending on your speed, I will just set one of these as the active turn mechanic. This will play a respective animation and then have different movement values read from in our substate system. They also each have a different length, how long they go on for, how much they dampen the player's speed, and how much they give the player force once you have finished this dash animation. And also different visual effects too, I forgot about that one. The way the turn mechanic works in a substate system is that the player's speed is dampened to a set amount. This is usually a negative amount in their current speed, so if we are moving towards the right, our speed could be a value of 8. We will want to dampen this value to a value of -4, for example, based on our dampening value. This would mean that we are going from a speed of +8 in the right direction to -8, meaning we are moving in the left direction once we have finished turning. So this is just playing for our animation and dampening our speed and then moving our player's speed value to the targeted speed value of the turning state class information. The way these values actually work in gameplay is very, very simple. All I do is I lock the player's movement direction, they cannot move anymore. I lock the player's input direction, they cannot make input turns. I lock the player's ability to jump, they can't jump. And I have the player turn. The animation is stretched to however long the turning animation is supposed to last for. So I just use a playback modifier for this. And then once this is done, we will lerp into our current regular movements. The player will also be given a set amount of speed once they have finished a turn, so a regular turn will have a set amount of speed of 0, but if you are running very quickly and you turn to make up for the skid, the very long skid that you are having to deal with, the player is given speed once they have left this skid. We then have the logic for if the player jumps or falls off a roof, and how this should turn the player. This mechanic is stupid and complicated and I don't like it, it's dumb. This is essentially the detection for when the player falls off a surface or jumps off a surface. We will detect if the player should reasonably be snapping their direction. This is different from a regular turn direction. This is an instant direction based on our immediate movements, and we just detect if the player should reasonably be swapping their direction. So, for example, if the player is on a roof, they are rotated 180 degrees, so the player is facing right, they will be, based on their rotation, looking like they are facing left and moving left. In this instance, if the player is to run off a roof with their movements, they will be running off the roof, they will have momentum towards the left direction, and they will fall off the roof, but based on their logic, they will still be facing right. So all we do in this circumstance is we detect that the player would be moving left once they have fallen off the roof, and we just snap their direction so they are facing left now once they have fallen off the roof. This just makes movement a lot more organic in the system space, because it doesn't mean that you're moving left and then falling off the roof and then moving right immediately. You're continuing whatever your momentum would have reasonably been, and we're just snapping the player's movement direction towards a new direction. The same is running up walls. If we are running up a wall and we are running right, we will jump off the wall and we will reasonably be moving left now that we have jumped from the wall. So all we do in this circumstance is we stick our rotational direction, we snap our rotational direction towards the opposite of whatever it currently was, because we just jumped off a wall. This is another one that's very complicated, figuring out of what is best to do, but it's pretty much just a logic-based system. We look at the movement direction, we look at the velocity direction, we see which direction it is pointing in, and then we just snap the player's direction to whatever it should be, if it is not what the current player's direction is. And by we, I mean me! Little old me, I did it all by myself. Next we have the turning animations. Mwah! I like these. These are good. Fun animations. The first one is the regular turn. This is just a player free frame animation of the player's turning. It moves very quickly in game. Very standard animation just to give the player the illusion of moving from right to left or left to right, despite the player's actual just Z position being squashed when they actually turn. The next animations are the turning medium. This one's pretty fun. This is the player's sort of skid, but not quite. This is the player moving pretty quickly and then turning their direction, so they are falling for the momentum, they're skidding a tiny little bit, and then they're turning around. This one I think is a fun animation. It had some nice weight to it and the player moving out of it at the end, but it is ultimately just a small animation of the player turning. The next animation is the player's turning skid animation. Mwah! Again. This is a really good animation. I like how this one turned out. It has a lot of weight to the player's actual movements. There's a lot of momentum behind this. You really get the impression that the player was moving oh so quickly, and then they turned. I like this animation a whole lot. It sure is a shame I'm going to redo all the animations in 2 weeks. Oh well. This one's pretty good. Finally, we have my favorite mechanic, one that doesn't do much. If you jump while turning, you do a backflip. Don't know why I added this one. Thought it would be funny, thought it'd be fun, thought it'd be funny and fun. It is. It's fun to perform. You have to be very precise if doing a very short turn, or you can just do it at any point when you're doing a skid turn. However, this does not have a huge amount of mobility movement in-game. It gives you a lot of height, which means that when you use a dash mechanic after a backflip, I guess that's useful. But overall, at the current point of the game, this doesn't have much purpose aside to be cool. Yeah, I don't really know what to do with this mechanic. I will probably make it so the player has a bit more aerial control, or maybe the player just goes higher, and then maybe in some circumstances, if the player were to dash out of this backflip, they would have some level of advantage in aerial mobility due to their accelerated height amounts. Maybe, but it looks nice, and I like it. And that's it for this devlog. If you missed it in the last one, these devlogs are just based on whatever I have currently coded that I want to talk about, and they have no real schedule. They are just whenever I make a video. So look out for the next one where I do something I don't know because I record these out of order of what I code. Probably jumps?